Okay, so now we're going to get into some actual large numbers. This here is called Knuth up arrow notation, and I alluded to something similar to this before when I talked about tetration and pentation, basically operations that go beyond exponents. But this is a much more formal way of doing that. It's a system of arrows, anywhere from 1 to an arbitrary number. And the way it starts is, let's do the 1 arrow example. So let's say we have A, 1 up arrow, B. This is very simply an exponent, so a to the power of b. Very, very simple. When you have 2 or more arrows, the rule changes a little bit. So if we have a with n up arrows, b, so you can imagine this being up arrow, up arrow, up arrow, n number of times. What you do is you write down this number of a's, so b number of a's, a, dot, 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 and this number of a's is b, and these are separated by n minus 1 arrows. So this might seem totally arbitrary, off the deep end or whatever, but you'll understand why it's defined in this way. And we'll just do some examples, just go through it basically. So let's say we know a up arrow b is a to the power of b. So let's say we have some actual numbers here. Let's take 3 up arrow 3. That's going to be 3 to the power of 3, which is equal to 27. Okay, that's easy enough. Let's move on to the 2 arrow example. 3 double up arrow 3, as it's called. What's that going to equal? Well, we'll use our rule up here. B number of a's, so 3 number of 3's. We write that down. Separated by n minus 1 arrows. So n in this case is 2. So this is separated by 1 arrow. And now we can evaluate this basically. And the same reason why exponents are evaluated from the top down in towers, Knuth up arrow notation is always evaluated from the right to the left. So just keep that in mind. So when we're evaluating this, we're going to start with this. You can imagine brackets around the right-hand side of this. And we do this first and this second. So 3 up arrow 3, what is that? Well, it's 27 because we evaluated this before, right? But let's just keep it as 3 to the power of 3. Then we go 3 up arrow, 3 to the power of 3. Well, what's 3 up arrow, 3 to the power of 3? It's 3 to the power of 3 to the power of 3. So we can basically think of this as the double up operation is a way of creating towers of exponentials this high. So it's a recursive way of doing exponentiation. So this is a tower of 3's, 3 high. So this is basically tetration. This is the idea of recursive exponents. So kind of neat. Just for instance, if we had 3 double up arrow 4, this would be 3 up arrow, 3 up arrow, 3 up arrow 3. And that would equate to a tower of 4 3's. So 4 3's in a stack, exponentiated. So pretty cool. Let's move on to 3 arrows now. So let's say we have 3 triple up arrow 3. We use the same rule as before. Let's scroll up a little bit. So we write down 3 number of 3's, 3, 3, 3, and separate that, oops, there we go, by n minus 1, which in this case would be 2, because 3 minus 1 is 2, up arrows. And again, we evaluate this from the right to the left. Well, 3 double up arrow 3 is something we already calculated. It's 3 to the power of 3 to the power of 3. So let's just calculate this out, just so we know what the answer is. So a power tower of 3's, remember we evaluate this from the top down. 3 to the power of 3 is 27. So we have 3 to the power of 27. And that's roughly equal to 7.6 trillion. So just so we have a number that we can actually plug right into this. So 3 double up arrow 3 is 7.6 trillion. So let's rewrite this as 3 double up arrow 7.6 trillion. Okay. Now what does this equal? Well, another way of thinking of double up arrow operation, as we said, is a tower of 3's this high. So what we end up getting here is a tower of 3's 7.6 trillion high. So that's pretty crazy. That's the triple up operation is equivalent to pentation, and this is truly something that would be very, very difficult to get to with just ordinary exponents. We need something that is as powerful as pentation to create something like this. This tower alone, written in this font, would probably reach out to the sun. Like it's insane. This is a truly, truly phenomenally big number, and there's really no way to even intuitively grasp how big this is. You have to imagine like the tower being evaluated from the top down, each stage getting larger and larger and larger and larger and larger, and going all the way to the bottom. It's a very, very truly gargantuan number that we don't deal with in everyday life at all. And still, it goes further than this. Let's do 3 quadruple up arrow 3. Same thing. Write down 3 3s. Separated by n-1 arrows, which in this case would be 3. And we put our brackets around. And now we know that this is that crazy tower of 3s. So let's just write like a little ... So we can rewrite that as 3 triple up arrow, crazy power tower of 3s, we'll call it. Now, what is this? Well, another way of thinking of this is performing the double up operation this many times, right? So we're kind of plugging this whole thing into the original equation or whatever. So we have, in this case, this would be B, and this would be A, and then we take n-1, which is 2. So this is basically like performing the double up operation. So 3 double up arrow 3, double up arrow 3, double up arrow 3, blah, 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 blah. I'll just write a couple more in here. This is like performing this whole thing this many times. This power tower of 3 is that 7.6 trillion high. So truly, truly staggering when you think about how this would have to be evaluated. You have to go all the way down the line here, figuring out this 3 double up arrow 3 is 7.6 trillion. 3 double up arrow that is a power of 3s, 7.6 trillion high. The next one here, let's just write it in, just so we have it. The next one here would be this number plugged into the next power tower, that many 3s, and the next one would be this number plugged into that power tower, that number plugged into that power tower, all the way down the line, and the number of terms you have in here is 3 to the power of 3 to the power of 3 with 7.6 trillion 3s in the tower. So it becomes very, very difficult to even explain how big these numbers are in terms of power towers and whatnot. And if we went to 5 arrows, I don't even think I would be able to come up with a way of explaining it. It's just the numbers are too big, and we have to rely on systems like this to denote them. We can't rely on exponents and stuff anymore. They're just too weak of an operation to deal with. So we're going to keep 3 quadruple up arrow 3 in mind, and we're going to discover a very, very large number indeed in the next video.